All right, so we are still working with section 5.2.1, and we're going to move into the next set of examples in your note outline. But before we do, I just want to review a concept you studied in Algebra 2 with radicals and radical exponents. Okay, so what you're looking at right here is this is a radical, right? And we would read this radical as the nth root of b. And then to the first power, there's b to the first, there's an exponent of 1 right there that we don't write. So we can convert this radical into a rational exponent, a fractional exponent, using the index of the radical and the exponent of the radicand, right? So that's a 1 right here. And the way it works is over here on the rational expression, the denominator of the fraction is always the index of the radical. And the numerator of this fraction is always the exponent of the radicand, the value inside. So an example here, this would be the 5th root of 7 squared. You can convert it into the rational exponent form by taking the index of the radical and writing it as the denominator of your fraction, and then taking the exponent of the radicand and using it as the numerator of the fraction. And we're going to use this example in the next set here. So we're working on number 9 right now. So this is the square root of negative 3 to the 4th power. So for all radicals, we indicate the root here, except for the square root. The square root is the smallest integer value we can use as an index. So there's always a 2 here, right? So that's the index. And then the exponent of the radicand is 4. So I'm going to rewrite this as radicand, negative 3, to the 4 halves power, right? And then in here, we can simplify this 4 halves into 2. So now we're dealing with negative 3 squared, which is 9. Be careful that you square negative 3 correctly. If you're using your calculator, make sure you group the negative and don't just hit, negative 3 squared, because some of your calculators, the graphing calculators, will often produce a negative 9 there. All right, number 10. Whoops, excuse me. Okay, complicated looking, right? A to the x to the 2nd power raised to the 1 over x power. So just because I showed you how to convert from radicals to fractional exponents and vice versa in the last example, doesn't mean you want to do that. Actually, radicals cause a lot of trouble. So whenever you can convert that radical into a fractional exponent, it's going to be a benefit. So basically, what I just did was I kind of just rewrote our expression here to make it, this 1 over x to look more like a fraction, but also to highlight the fact that the property that we have to use here, right? So we have a power raised to an exponent. So we're going to multiply the 2 exponents together. So it's x squared times 1 over x. The x's are going to simplify. And then I'm just left with a to the x times 1, or just a to the x, right? So definitely complicated, but we can simplify it in one step. Next up is number 11. This is b to the x raised to the x minus 1 power divided by b to the negative x. So there's no rewriting the base as a prime number at this point, because these are all just parameters, b's. But I'm going to use my property, right? And I am going to kind of follow order of operations, right? So I'm going to work in the numerator first. There's nothing I can do in the denominator. So I'm going to multiply these exponents together. That's the rule. So x times the quantity x minus 1 is x squared minus x. Make sure you distribute this first exponent to both terms here. And then it's divided by b to the negative x. Both the numerator and denominator are in the same base, b. So we're going to use that quotient property and subtract our exponents. So it's going to be x squared minus x minus negative x. And be careful, if this denominator has 2 terms in it, you want to group it so you make sure you distribute this negative correctly. At this point, it's just a matter of combining like terms, if possible, right? So this is really going to be x squared and then minus x plus x, which is just 0. So now we have b to the x squared. And you can express it this way, or you can just literally express it as b to the x squared. It looks kind of funny, but that's how it plays out. And then number 12, right? So 2/5 to the negative third power. So this is kind of I guess best to be described as a shortcut, but you can quickly deal with it. And this shortcut doesn't really expire if it's just a single fraction like this, right? No additions or subtractions. So 2/5 to the negative third. First thing you want to do is, can I express this as a prime factorization? 2 is prime, 5 is prime. There's nothing we can do there. So you could express this as 1 then from the negative exponent divided by 2/5 to the positive 3 power. That's the reciprocal. So that's just going to multiply the numerator by the reciprocal of the denominator, and you end up with 5/2. So basically, single fractions raised to negative exponents, you can just take the reciprocal, 5/2, and then it's raised to the third power. And then here we're going to raise each of these, the numerator and denominator, to the third power. So 5 cubed is 125, 2 cubed is 8. And that's it for these examples.